on mathematical aspects of artificial intelligence and the data science. And before moving on to this session, let me have a word of appreciation to Savita Engineering College who have taken this initiative to make the students to understand what is kind of this artificial intelligence and data science through the various webinar programs. So and also, and gives me a great privilege to be the part of this program to share some of my knowledge which we are working today in accordance with that kind of an application to share with you. So this is going to be an application point of mechanism. I'm not going to bore you with a lot of mathematical aspects and everything. So we are going to talk about what is a data science is about and what are the things. And second thing is we are going to concentrate about the designing about the model. So how far the model can be designed for a particular data. So that is the most important criteria where the industries are facing a vital or facing a very big problem towards that. And I'm going to share with third point, I'm going to share with some of the projects which is going ongoing projects. That is the real-time projects which today is mandatorily needed. And fourth is about deployments, what are the tools you can use and what are the real-time scenarios you can take an aspect. And these are all the things we are going to club into a single module. Okay, so this is what my session is going about. And before starting up the session, this is not going to be a traditional PPT running session. Actually, it is going to be like I'm going to show you the slide, and moreover, we are going to have the discussion. So we are going to have the discussion with a number of case studies. Okay, so the number of case studies available. So let me have this logic actually. So what we are going to do today, though this is my uh, presentations sneak peek. Actually, what we call sneak peek is something the gist of my presentation is going to be like from the film. And we are going to take the different case studies from the film actually. So we are not going to consider the real-time data, even though we are seeing a lot of data with that. We are going to see that what we see, like this is the film which gives you the lot of insights about AI and data science and machine learning and deep learning, whatever the studies we are doing today. So we are going to take this as a case study and we are going to solve a lot of problems with that. So model with the help of that. So guys, like it will be in Tamil, don't worry, like I'll explain you the scene, problem and everything, and then we'll move on to the design of a problem. So this is from the film Endiran, all right? So now we'll start with the basics. We'll start with the basics, fundamentals of AI. What is required for an AI and where comes the data science and where comes the data analysis and what is called the artificial intelligence. So let me have this as a basic block diagram for you. And this is the basic block for your AI. So first of all, when I talk about artificial intelligence, so artificial intelligence is not only implemented in robotics, right? This is just I want to give to you. It is not only it is implemented in your robotics. First, it has been applied in your most important area where we are coming across here is the security. So cyber security now it is going something in a very advanced model with with the help of an artificial intelligence. Second is healthcare devices, which we are working today, the integrating this healthcare devices over the hardware with the help of a machine learning. And I tell you a device that is called what we designed. It is a device which is normally utilized for a social distancing, right? So this is kind of an application. Third, it is utilized in electrical vehicles for better chargement and everything. And most importantly, it is utilized in all your network facilities. For example, when you want to work on IoT, because this word is also familiar, the IoT needs AI. Right now, I'll talk about how these two fields are clubbed. And second thing is BAN, we call this body area network. And third, we call this connected vehicles. That is most important. You may come across the connected vehicles or autonomous vehicles where this AI plays a vital role. So these are all the applications. And finally, we are implementing in manufacturing. Okay, so manufacturing industries or industry 4.0. And these are all the things which we are coming across AI. So first thing is, first you have to put up your mind that artificial intelligence is not only utilized in robotics. It is utilized in all sort of the fields what I discussed and what I told you. It has all been implemented. And most importantly, can you imagine this artificial intelligence has been primarily utilized in the film industries also, right? So this kind of logics we have made it. So remember, the artificial intelligence is not only for robotics. It has been diversified and it has been utilized in all the fields, right? So now we'll go for the first block diagram, and the first block what you have in the artificial intelligence. Remember, it is the block which you can apply for any category of a field, what I told you, right? So it is not only meant for one particular field. When you want to start something called the artificial intelligence on particular field, Definitely this block you can utilize it and you can use for any application. So first thing what we come across here is the first is your design of your data model. So the data model is important. The data are important. So you would have seen in the film called Irumbu Thirai, right? The Tamil film, which stars with Vishal and Arjuna, it seems actually. And the film will talk only about the data, how important the data is. With the help of a data, you can do it a lot of wonders actually. So whenever you want to design the artificial intelligence algorithm or something like an AI model for that, you need to go for a collection of a data. So data model is important, and how to make the data readable by the user or by the machine, primarily by the machine. We call him as a data scientist, right? We call him as a data scientist. So second thing is about data is important. Second thing is about the data scientist. So how come I'm making the data that is readable by the machine? How come the machine can understand the data what I have collected? So that is known to be the part which has been done with help of the data scientist. This is the second point. Third point regarding the data is the data is dynamic, right? So this is, you have to accept that you're not only focusing on the data only with the can be downloaded from the internet sources, nothing like that. The data can be dynamic system. For example, it can be a video, it can be a speech, it can be a most importantly a document, or it may be any from the sensors, from any kind of a devices, anything. So we must be aware about that one device. If we have dealing with the data we cannot fix it as it's a static one. It is a dynamic model which can be varies according to the different applications. So this is the most important case of the data. And the fourth important point what you come across in the data is nowadays, like, you have to working on the data. So the collection of data is important. So where do I collect the data, right? This is one point. So first point, you can download it from the internet, like something called Kaggle and UCI respiratory. But in industry, we are working on the real-time data, right? So the real-time data where the IoT comes into the picture. So here the IoT is utilized, the Internet of Things is utilized to extract the different category of a data, and so that it can be fixed on my server, and I can do and I can manipulate and I can design a model, right? So this is the logic. So IoT doesn't mean that it is only for storing the data in the cloud and seeing whatever you want. That is not the case here. So the data is being utilized, data collection unit that can be done with the help of the IoT stuff. And in case of the real-time scenario, you have a lot of softwares which is available to collect the real-time data which is available, such as which I told you for a connected cars, I told you something for electrical vehicles. There are a lot of softwares which can be working on the real-time scenario, and that data can be collected for an application. So you must aware about it. I'll tell you what are the softwares which are available. So this is all about the data. So data, so first of all, remember, data is important. Without the data, we can't able to do that. Similarly, like what we do for an examination, we used to study a lot of, not studying a lot of books, like we study a lot of question banks, and the question banks will have a lot of data, right? A lot of data, and that data is important, and data is not static. So the formula here is data is not static, it is dynamic, it's going to vary it, and we are into the solution. You should provide a solution to solve that data, and the people are known to be a data scientist. And fourth important thing is, where do I collect the data? Data collection unit can be either it have a predefined data which has been uploaded in the software, uploaded in servers like Kaggle, UCI, and etc. And if you want to work on the real-time data, we need to go for an IoT kind of a stuff. So IoT, if you have that, IoT can be utilized for a logic. So this is all about the data what you have, right? And the second, what we talk about this database collection. After the data are fixed, but we need to go for the database collections. And most importantly, we have a feature extraction. So feature extraction, what do you mean by the feature extraction is, the feature extraction may or may not be required. It depends upon the data, how much data you have collected and how much volume of data you have collected. So that makes you to choose for the feature extraction, right? So if you have only 10 data, so no need for a feature selection. You can directly give to the what you say, like the learning model or whatever the case, and you can do the decision, right? So that is that depends upon the volume and category of characteristics of the data. We need to go for the feature selection. What is the feature selection? Best example what you come across here is, for suppose if we do a 5 years of question bank, if we study, for example, if I want to study the 5 units, right? So for an examination or a test, so what I do normally is, like, I used to collect the important keywords, right? For example, if an artificial intelligence is, what is define an artificial intelligence, define what is artificial intelligence is, I'll take what is artificial intelligence. Artificial intelligence is as an important word, and the definition as an important word. And second unit, I'll take some other word, machine learning. Machine learning as an important word. And the important words are taken, important keywords are taken from the each and every unit, even though you have a lot of topics in that. So this is known to be the feature extraction, right? This we called as a taking or extracting the important questions from the question bank. It's very simple. So extracting the important or repeated questions from the question banks. So this is known to be your feature extraction that represents the characteristics of whole data, and that I can do for an application. And third point is about this, the intelligent learning. This is the point where you have the machine learning and the deep learning comes into the picture. And this is the word which we are coming across. We'll see later on this, what is the deep learning and machine learning is about. And finally, there ends with the decision box. So what normally we people do is we'll stop only with the intelligent learning. That is, we will test the algorithm, whether the algorithm behaves correct or not. Whenever you study any courses in the world, actually, even if you take Coursera or Udemy, whatever the case you want to take it out, you can see the algorithm, and the algorithm is fit into some problem, and you will see which algorithm has the better accuracy. That's it. You will study only about the behavior of the algorithm according to the data, but we never concentrate about the behavior of the whole system. That is to be taken with the decision box, right? That has to be taken with the decision box, and the decision box involves on the deployment. So you have algorithm, and you have chosen the algorithm, and you have chosen the data, everything is fine. So you have to deploy it on the particular model or a particular hardware or a particular application scenario, everything, and test how this whole blocks works, right? So this is the most important case where artificial intelligence plays a vital role. So if you want to design, if you want to predict the diagnosis, right? If you want to predict the diagnosis, or in industry, it's an example project actually. Everybody is working on the fault tolerance system in the industry 4.0. That is, fault tolerance is something like, or a fault diagnosis something like, it has to detect the fault, right? So now we are in the position to design a new model which can able to pre-diagnose the fault, right? Hope you have understood the problem here. Pre-diagnosis of the fault. So if I want to design the pre-diagnosis of the fault, I have chosen the data from the different sensors and different machines and put up a database. I collected the feature extraction, and finally, like, I made it some algorithm, best algorithm. Okay, let us assume it's XYZ algorithm that produces a good accuracy, right? If I stop here, I can only tell you like that the algorithm has the best result on the particular data, but it never ends on that area. So algorithm definition, okay, after testing, it should be deployed in the current scenario. So if some fault is occur, how far my whole system works, that remains to be the real challenge of an artificial intelligence engineer. So remember, guys, so don't stop only with the case of testing your algorithm. Instead, deploy it and see what is the behavior of whole model on the whole environment scenario. So this is what the most important artificial intelligence is all about. So this model, this basic model, you can imply for any kind of application. You can apply for anything what we talked about. So this is the application, you can go for that. So I hope you have understood what is the artificial intelligence model is. So this is what the differs, the data analysis, the data science, and the artificial intelligence engineer differs. They deploy it on the hardware, they deploy it on the scenario and test what is happening. Again, a calibration, testing, everything will take place. So this is the most important criteria what we have to come across here, right? So this is the basic model. Now I'll go with the data model. What the data model is. So first thing is, we talked about data model, different categories of data model. That is dynamic, it should be a dynamic, and it should be like a collection of units, should be from the IoT or any websites, right? So once you have the data, what is the first step you have to make it out is data pre-processing, right? This is the logic. So what is this actually? So why it is important, right? I'll tell you a next project, right? Next important project. This artificial intelligence and the implementation of machine learning and deep learning has taken its new edge of development with the help of sentimental analysis. Everybody knows about that. What is a sentimental analysis? Is something like, if an example, like if you have a tweets, if you have a messages over you, right? An example, we are working on some project called, if you post your message, I can tell you who you are. Sorry. That is, if you post a messages, I'll just calculate your continuous messages from the day 1 to day 10, and with that I can able to analyze who you are, who you are mostly, and what is your intention for posting this message. I can able to give you that. So this is the sentimental analysis. Okay. So this sentimental analysis is implemented not only for the analysis of human behavior, it is also nowadays it is utilized for reviews of from the products and everything. Now we have been implementing for the human behavior, right? That is the different concepts. So what I do is something like, hi, I'm fine. This is the word which has been given. So, and there is like a intentional word. There is something called, there's a intentional word which hurts others. So I don't want that word, right? Hi and fine. I don't want it. So something I need only this word. So cut short it, and I need only the word which can be implemented. So this is pre-processing. That is removing the unwanted data in my data set. This is most important, right? Unwanted data. So making all the unwanted data, making a precise data so that the machine can understand clearly. So this is one point of a data pre-processing. And the second point, what we come across here is in deep processing is making a meaningful data. Okay, you have made it, you have made a remove all the unmeaningful data and made a meaningful, that is a valid data. And second thing is you have to make it equal and meaningful data. What is it all about is, suppose, for example, if you want to have an heart disease diagnosis system, so if the ECG shows 0 and you have a BPS something 130, there is no kind of a data which is being related with that. So you have to put up the meaningful data. If it's 0, just take it about, measure once again, and make a meaningful data. So this is known to be the data pre-processing. That is removal of unwanted data to make a precise data. And the most important word I'm using is, it is to be the valid data. So valid data has to be made. That is meaningful and valid data has to be made. So this is the two important objective for designing the data pre-processing logic. So data pre-processing is something like that. This is where the data scientist will play a vital role. And moreover, it is not only deals with your sensors. This is what my point is. This is not only dealing with the sensors. It is dealing with your, what I told you, voice messages, videos, everything. So they're dealing with a lot of diversified data. This is data pre-processing. So what I do, sir, what I can do with the starting of this, I'll tell you the deployment tool which can be utilized here. First thing is, whenever you have the data, you need to visualize the data. What is the data is all about? So what can be done with this, right? So first, everybody knows about Python, right? Everybody knows about Python. So the Python is normally utilized here. And what we are supposed to, what we can make it here is, other than the Python, we have a library in Python. We have matplot library. With the matplot library, you can see, visualize the data and everything. And what we suggest to visualize the data is, you can use Tableau, right? Tableau, Tableau, right? Tableau data analytics, right? And Power BI, right? So this is the next word, is a Power BI, right? Power BI. So this is the next word which has been coming into the picture. These tools can be utilized to visualize what kind of data you are processing is about. So you need to process the data. So first is visualize the data. So you can use these two tools, but unfortunately you have only a trial version for this. And this is mostly most commandable field which is required today, actually, to work on the Tableau and even on the Power BI. So these are all the tools which is required for that, right? So these are all the logic. And before moving into that, if you have a lot of data, so we told you, like, it has to be converted from the unmeaningful to meaningful if necessary, right? So you need a storage. You need a storage to work on the data, right? So DBs, databases are required. So here in industry, we normally utilize SQL, right? In industry, we normally use SQL for storing all kind of data, and that data will be visualized, can be visualized with the help of integrating with the help of Tableau and Power BI, right? This is one step, right? And second thing is removing, you can remove manually or by the program. That can be done. So seeing what is 0 and everything, but only human can understand what is the problem in the data. So this is manual removal of the data. After manual removal, I'll store it new data in my summaries. Okay, so this is the logic of a data pre-processing. So this is one kind where the data is ready. That is, the data is ready. We have a lot of data from that. We have made the data is ready right now. So now after making the data ready, now we are going to concentrate about the model. So the learning model which is to be imparted on my data to get my accuracies, right? So this is the logic. So now hope that I just told you the 3 important scenarios for working on the data. I repeat once again, it is on SQL for storing the data. It is most important today. And the Tableau, which is for the data visualization, data analysis, what we have called as, this is most important, and Power BI. These are the 3 things which you can integrate for a kind of a data, which you have the data, store it on my SQL and see what is happening, and then remove the data, whatever you want, and make a meaningful data. Now, assuming that we have made the meaningful data right now, we are going to move on to the learning model. Okay, so this is the real stuff. If you want to start the learning model, if you want to start, there is a thing actually, right? It's, it's a famous characters from your Harry Potter, right? So what is the real scenario, right? So the Harry Potter asks us like what happened to him, and he answers is study the match behind the deep learning. So it's a learning algorithm. So it's a thing which we have been finding across a very difficult manner for finding out the max. What are the mathematics involved in the deep learning that makes you stuffed, right? So this for this kind of an application, so how to understand, even though we are saying that it is a difficult task to understand and it makes you to break your head like anything, right? How can I understand the model for that depends upon the data. So this is what we are going to do today. That is, we are going to have a different case studies, what can be done with that. Okay, so now I'll move on to the first thing about the case studies. So before moving into that, the models, I'll just discuss you with machine learning and the deep learning model, right? So when the learning model is concerned, why do we learn? Because learning is a part of an artificial intelligence, right? That's why I told you everybody will be stopping with the learning model, never deploy it for an application. So what is the basic logic of a learning model is it needs a training of data, and finally we have to test it in the real-time scenario. This is what the logic is done, but we have a ratio that if a whole data is available, 70-30 or 80-20 or 60-40 can be utilized for training. So that is for testing the algorithm. But here in the case, we train everything and test it in the real-time scenario, right? How the algorithm works. So here you have machine learning, you have deep learning, and third, you have reinforcement learning. Okay, this reinforcement learning is playing a vital role in the 5G networks, right? It plays a very, very important role, even though our country has not been equipped with 5G, but in a simulation scenario or in other countries, this 5G has been equipped with a reinforcement learning. And finally, the most advanced algorithm, what we call today is self-adaptive learning algorithm. Self-adaptive learning is something like it learns by itself. So it is a one-time training. If I train you for the first standard, I need not train you for all the preceding standards, right? You will train accordingly by studying the books. So that is self-learning algorithm. So there's a 4 categories: machine learning, deep learning, reinforcement, and you have self-learning adaptive. That is, it is adaptive. I'll tell you what is adaptive is. So now we'll just concentrate on the basic hunch, that is machine learning and the deep learning. So machine learning has the subset of a deep learning. So I'll repeat once again, machine learning has the subset of deep learning algorithm, right? So deep learning algorithm, what do you mean by, we'll talk about later. So what makes the difference, right? Why do I choose a machine learning and why do you choose a deep learning? So there is a word actually where I go for. It all depends upon the data. Again, so if I want to choose a model, depends upon the data. How much volume of data you have depends upon that. We have to select this machine learning and the deep learning logic. If you have only a small amount of data, for example, don't make it like small amount of data, it is 10 or not. Let us assume, let us be fixed at a threshold. It is less than 1 GB, right? It is 1 GB. It is not so actually, it's an example. Let us assume we have the data which is less than 1 GB. So what happens in 1 GB, like less than 1 GB? So what is the logic which comes across here is like we can provide a machine learning model. If the data is increasing beyond that 1 GB and you have like 1 TB of data, images and videos, a lot of inputs like that, we can integrate a deep learning. So why I can't able to learn, why can't I deploy this deep learning over machine learning and machine learning over the deep learning? So when you work manually, when you practically work on, so don't bother about your Googles and everything. When you work on practically, what problem you'll face when you interchange these two is, first thing is you have to understand an example. There is a 6th standard student. I cannot dump his brain with the IAS syllabus, right? This is the logic. I can dump him. I can dump him with a lot of syllabus and a lot of logics with that. But at present, and what I cannot able to attain what is the output is required. So this is called overfitting in the algorithm. So once the data increases, the machine fails in some order, right? The machine learning fails in some order. If you are supposed to write, for example, when we start doing our examination, when we prepare for an examination, we will do normally before the examination, that's a day before the examination, right? Assume we are starting, when you have an examination by 10 a.m. by tomorrow, we'll start by this time. For example, we'll start by this time, by 5 o'clock, we'll start this. And what we do is we will not dump our brain so that with all the units, all the subunits and everything. What we do normally is we just normally take as some kind of an important points, dump it, learn by self and behave it. So this is the process of a learning. So machine learning, if you replace the machine learning with the deep learning, there will be the problem of that. And that problem is a overfitting. So this is the basic mechanism. And moreover, if you have lot of data, when you want to study for an IS examination, it is not only required to study only for the 6 to 10 syllabus, is not required to study for the IS examination. So the varies, the application varies. So that is preferred for the deep learning, and this is preferred for the machine learning. When you have small data, small volume of data, you can opt for machine learning, simple. And when you want a large data to be processed, then we can go for a deep learning logic. This is the one kind of an application, right? So this is the difference which draws the line between ML and DL, which is primarily utilized. And second point is how to choose the model. So this is what we are going to come across here, how to choose the model for the different applications. So first thing is data is there, and we'll talk about machine learning first, and then we'll come to the deep learning algorithm and how to deploy the deep learning algorithm on the logic. So now I'll share the first thing about mechanism. So case study starts over here. We'll start with the case studies. What is the case study right now? And you can visualize the film, right? And now we can able to see you. I'll explain you what is the done, right? So hope you're seeing it actually. So this, right? Everybody is seeing this film actually. Everybody is visualizing the video. Hello.
Yes, sir. They are able
Yeah.
to see it, sir.
Yeah. Thank you. So now we'll start with the first case study, right? So now you just visualize the scene. I'll explain one by one what is happening. Then we can make it out, right? So this is the scene. Like, what is the scene is all about is it is to find out the odd man out, right? This is the logic. Now just carefully watch the scene. Don't make it with Aishwarya alone, right? Watch the scene. I'll explain you technically how the algorithm is integrated.
இந்த ரூமுக்கு வேற ஒரு ரோபோ சாப்பாடு கொண்டு கொடுத்துருக்கு. 10 நிமிஷம் கேமரா வேலை செய்யல. உன்னோட திடீர் பிரமாற்றம், கரண்ட் கட்டு, ஜெனரேட்டர்ல தண்ணி. வசிகர் நீங்க தான் இருக்கா. என்ன ஏமாத்திரியா சனா?
இல்ல சிட்டி.
என்ன லவ் பண்றேன்னு சொன்னது போய் தானே?
என்ன நம்பு சிட்டி.
அப்போ என்ன உண்மையிலேயே லவ் பண்றியா?
ஆமா.
அப்போ வசீகரன் உயிரோட இருக்க கூடாது. வா, வசீகரனை கொண்டுடலாம். நம்மளை அழிக்கிறதுக்கு நம்மள மாதிரியே நமக்குள்ள ஒரு கருப்பு ஆடு நுழைஞ்சிருக்கு. அதை கண்டுபிடிச்சு பலி கொடுக்கணும். டாக்டர் வசீகரன், நீயா வந்துட்டேன்னா உன்னை ஒலிக்காம கொல்லுவேன். நான் கண்டுபிடிச்சேன்னா உன் சாவு கொடூரமா இருக்கும். Rubber. வசீகரன் நீங்க இல்ல போதிருக்கு சனா.
ஆமாமா.
ரெண்டுல ஒன்று தொடு. அப்போ வசீகரன் இங்க தான் இருக்கா. என்னாச்சு சனா? தலை சுத்துதோ? இப்போ சுத்தம் பாரு. Soldiers, rotate your heads.
So hope you have enjoyed this scene actually, right? So This is a scene which clearly depicts you what is a learning algorithm and model which can be designed. I'll explain you technically what is happening. The first thing is about is first step for designing a model, right? What is here is like you have 100 chitties, right? 100 chitties is nothing but you consider this a 100 datas. You have 100 datas. And the output is defined here. What is an output? It has to find out the odd man out, right? Very simple. It has to find out the odd man out. That is, it has to find out, it has to differentiate the human among the robot, right? You can see here the input and output are known here, right? Input is known. We have 100 data and output is known. What is to be done? What is the output to be obtained, right? So what is the output to be obtained? That it has to find out the human, right? This is known to be supervisory learning, supervisory methodology. Right? Hope you have understood what is supervisory. Supervisory input and outputs are known. That is known to be your what we call as a supervisory. When we talk only about the inputs, we don't know what is the output to be obtained, but we will play with only category of inputs. We call this a unsupervisory, right? This is the two difference, right? This is the two difference what we come across here. The supervisory, here it is, we have group of data, what you've seen today, that you have a group of data, and from the group of data, it has to differentiate or find out the odd man out from the group of data. So output and inputs are known. So that is known to be the supervisory algorithms. And all your machine learning and deep learning comes into this category. So all this comes into this category. And you have an unsupervisory algorithm where I just play with your unsupervisory logics. And most importantly, it will be utilized for categorizing your input data. It has been normally utilized for the categorization of the input data. That is known to be your unsupervisory logic, right? So from this, we've been clear with this, right? The second point regarding this scene is something like what happens here is, so once you want to output is defined that it has to target on the human, right? It has to differentiate among the human, right? So what happens is the master machine chitty calls, and every data, every robot, I'll call the robot as data right now, and all the data is assembled in a single thing, like a single row and column, right? Or a single place, right? Where the machine can able to understand. This is what we call as a pre-processing. This is what the logic of pre-processing, right? Now, what it happens here is it takes the features, right? For example, it scans the body, it scans the body temperature, it scans the sweat, and most importantly, it cuts the head, whatever the you want, it cuts the head. And finally, what happens is, and it also asked for the rotation of the head, right? So every feature has been taken into the application. This is known to be the feature extraction. This is the logic we call this a feature extraction. You would have seen in the film that there will be a body scanning, there will be a cutting of heads where the chitty finds out it is a robot, and there will be a kind of a sweat where you can see that the sweat is being controlled, or sweat is being sweat out by the human, and he controls the breath also, because by the breath it can able to understand who is coming over here, and moreover rotation of a head, and then he has been caught, right? Forget about the catching, how it catches, that is different. So this is known to be the feature extraction. So hope you have understood what is feature extraction is. So now we have to calculate everything on the data. Third step is we have to analyze it. We have a data pre-processed, assembled, and we have taken the different features. Different features are there, right? And from that feature, it has to make an understandability that it has to differentiate the human. This is the logic, right? Now, what happens here is assume a condition, right? If the chitty sits in the table and calls every robot and measures the features what I told you, then this methodology is known to be adopted for machine learning. What it implies is machine learning does not come with a feature extraction. So this is the line I want to mention it out. So machine learning does not come with a feature extraction. So the feature extraction has to be studied and has to be implemented by the programmer or a developer separately, and he has to integrate with a learning model, a supervisory model, learning supervisory model. So this is the simple drawback of a machine learning. But whereas in the deep learning, the feature extraction can be the part which has been shown in the film, right? Feature extraction is the part, right? So this is the another line which makes the difference between the machine learning and the deep learning logic, right? This is the next thing. Third, now what's the problem here? What is the problem you come across here, right? The problem here is we have data, it finds out who is the output has to be determined, it takes feature, okay, right, over. But what is the exact problem in this scene is, you can see here all the data are similar, correct? All the data are similar. So you don't have a differentiation among the robot and the chitty. That is the major problem in the logic. You have similar data. All the data are similar. So how can I able to find out the difference of data or from the similar data? This is the problem number one for selecting your learning model. So how do I select it? You have only a group of data. Once the human goes there and he visualize all the data with help of that. So what I can do is I cannot able to make the difference. That is the big question mark, because on seeing it, every data is common. So I just conclude there is no human at all. But the thing is, the machine has to identify it. Machine has to identify it. So this is the basic problem what we have. When we have a group of similar data on the databases or a group of data, how can I able to make a difference on the similar data? This is the most important cases what we have today. So what is the solution for that? So this is the first machine learning model. So what I can do is, let us assume, let me plot x and y, right? X and y axis. One for x for human or y for what do you say? It's a robot. It's a chitty. So what it does, it takes the different features. First, body scanner. I plot the body scanner. It fails because it cannot able to identify it. Second thing is about it checks the sweat. It fails again. Checks the breath. Fails again. Cuts the body. Fails again. So everything is scattered. When you visualize it, every data is scattered. There is no kind of relationship which makes the difference. So one, and finally, there is one kind of feature that makes the difference between your robot and the human. That is your rotation of the head, right? So by rotating, the robot can rotate the head for 360, whereas the human can't do it. So this one single distinct feature will make you to understand he is a human. This is very well shown in the film. So when I plot it, these two feature comes out because all are equal, these are unequal. So when I draw the line, this feature will be remains closer to each other, right? This remains closer to each other. And this kind of a machine learning model is known to be support vector machines. I repeat, it is called support vector machine, even though it is older one, but we must know about it because we have some other cases for implementation. It is known for a support vector machine. So what you understood from the support vector machine, when you have a similar data and I need to differentiate among the difference of data from the similar data, I need to go for SVM. How does my SVM works? The SVM is considered to be the most powerful because with one single feature difference, it can able to identify the object or output, right? This is the most important. This is where, so even though you have a lot of feature, only one single feature that makes the difference. That is your rotation of your head. So that rotation of a head with the one single feature difference, the learning algorithm can learn it and it can able to classify, or it can able to classify the odd man out or a human from the group of similar data. So this is the model. Whenever you was working on a kind of a similar data and you need to find out the difference of data, identify the difference of data from the group of similar data, kindly the SVM can be preferred more. Right? SVM can be preferred more for a kind of an application, right? This SVM can be utilized for support vector machines, right? This is the first kind of a learning model, right? Hope you have understood actually. So this is the logic which we have to come across here. So that is the logic we are going to share this. So again, I'll share this. So this is the first model which we are coming across here. This is called SVM, support vector machines. Okay, this is known to be the support vector machine. This is the, I'll repeat you once again, if there is a group of data, similar data, and from the group of similar data, I need to find out the difference of data. This is one kind, right? And the second application, what we are going to have a case study is something like, we'll go for the next case study. So now I'll put up a question for you, right? You want me to just message me like what kind of learning algorithm is this, right? So next thing we are going to start with the next case study. Yeah.
Oh. Chitty, stop the car. Sir, five minutes கிட்ட தெரிஞ்சவே முடியல. நிறைய பேர் உள்ள மாட்டிக்கிட்டு இருக்காங்க. இமிடியேட்டா வரத போஸ்ட் அனுப்பி வைங்க சார். Chitty, உன்னால அவங்களை காப்பாத்த முடியுமா? Heat 799 degrees Celsius. எனக்கு 1000 degree வரைக்கும் ஃபயர் ரெசிஸ்டன்ஸ் இருக்கு. என்னால Chitty, எந்த ஊருக்கு ஆபத்து வரப்போற? ஓகே.
So now this is a second case study what we have taken into an account actually, right? Uh, whether it is supervisory or unsupervisory. Any answers, guys? Whether it is a supervisory or unsupervisory.
Sir, they will not be able to interact
Oh,
now,
okay,
sir.
okay, okay, okay. I can
The
understand.
last, yes, last only we will have the question and answer
Okay,
session, sir.
okay, ma'am.
Okay, sir.
Okay, fine.
Okay.
Thank you. So what happens here is this is something a supervisory algorithm. What is the logic which we have come across here, and what are the mechanisms we come across here is something very thing that is like you have data, that is the people are there, and output is fixed that it has to rescue the people. So input and outputs are fixed. So this is the logic. So hence we call this a supervisory algorithm. So what is the rescue? You have a difference data. So you need not worry about here. So there is no kind of a similar data over here. You have a very difference of data because we have different kind of a people over here. So we have a different data which is already there. So what happens here is it has to find out who is alive or dead. If he finds it's alive, it has to rescue it. This is the logic. So this is the basic logic behind this scene, and this is the algorithm. So how the learning model comes into the picture here is I can have the two cases on this on the data. One is something called applying the if conditions over the data. That is, it sees whether he's alive or dead. How can I able to confirm that he's alive? It has to measure the breath, temperature, even voice and everything. The face recognition, whatever you are doing right now, right? That can be taken into an account. So once I put up the if conditions, if classes over the data, if I put a lot of if classes over the data, so what I can do is I can able to find who is alive or dead, and from the alive he can able to take a decision. He can able to take up the decision, that is to rescue it. So this is known to be your decision trees. Okay, this is known to be the decision trees. So decision trees are nothing but applying the if conditions and if classes over the data and to classify for an application. So this is known to be your decision trees, and it plays a vital role in the case of your security breaches. So security, whenever you want to have a cyber security, whenever you work on the security what we come across in the hardware on autonomous vehicles, this decision trees can play a vital role, but with some drawbacks, right? And the second scenario of making up a data is you can apply the probability theorem, right? Applying the probability, whether the probability of alive and dead, solving the probability of alive and dead, and with the help of the result what I obtained, I can go for the rescue. This is known to be your Bayes theorem, Bayes. That is Bayes theorem, and the whole classifier learning model we call this NB theorem, that is naive Bayes theorem. Okay, so this is a naive Bayes classifier which works on the probability of alive and dead. Who is alive and who is dead? So we'll make it a probability, and with the probability we can able to classify and we can fix up for a rescue. But in the first case, we will apply the lot of if conditions over the data, and from that data we can able to find out the alive, and from the alive I'll go for a decision. This is the second category, that is for a decision trees, and the NB. This is the third thing, right? So what you face here, what's the problem you face here is whenever you work on the large data sets, right? When you work on the large data sets, this NB and decision tree fails miserably. This is what is happening here, because the if condition is assume it is working on decision tree, right? The machine has not been given with a standard with a if condition. That what happens is it has not given the if condition. For example, it has to rescue the girl with a dress or a human with a dress. That condition is not being formulated over the machine. So what happens here is the machine fails miserably. So if the data sets increases and if you want an accurate model to detect it, everything, you need a lot of decisions, a lot of if conditions has to be imparted on my data. So if you miss out any kind of a condition over the data, then if the condition occurs, my system fails miserably. So that's why it is not being utilized for the logic, even though it plays a vital role. That's why I told you it's a small drawback, right? So that is what we called as a NB and the decision trees. This is a case studies. Okay, so three algorithms we listed out, and fourth algorithm what we are going to make it out here is the most important algorithm, and this is the deep learning or everything is the base for that. That is called artificial neural networks, right? Artificial neural network is the base for deep learning as well as for your any machine learning model. So these are all the models which are available. We have another model we call as KNN, and we have random forest. and we have called as a boosted algorithm. We'll see later on what is all this algorithm and what is the application of that. So now we'll move on to the artificial intelligence algorithm. So, sorry, artificial neural networks. What is this all about? Neural network, come across this word is familiar, and it is, you can see a lot of things which we coming across here, right? So what is the logic we come across here in the mechanism of artificial neural network is we have input and we have output, and it's a hidden. So it's a supervisory, nothing but it is a supervisory learning algorithm. So what makes your input and output and hidden? Why it is called? So similarly to our human facility, what the human has is input, and it is processes in the brain, and it finds out the output. So this is the layer: input layer, output, and hidden layer is nothing but the brain, which consists of a lot of neurons, and we call this a hidden nodes in the technical, right? What happens here is now the input layer has to be, that is input data has to be connected with the hidden neuron. That is done with the help of a mathematical application. Every feature which is considered as an input should be connected with the hidden neurons, right? Whatever the hidden neurons is to be defined, and output, it should be given an output. So now the problem what we have is how to choose this hidden layer, right? How to choose this hidden layer, because it consists of a lot of hidden units. I cannot able to fix up. I can get a lot of accuracy. I can get more accuracy on this particular hidden neurons, or 50 number of neurons, or 100 neurons. I cannot fix up that kind of an application. So that's a major problem what we have right now. So how can I fix this? How can I make the fixing of this? So what is the role of this? Why I should fix it? Why? Because it is something in, I'll take an example. For example, if a teacher comes to a class and she or he handles the classes, right? So for example, if the students who have been seated in the classroom only knows our Tamil language, right? They don't know about French, and but the teacher teaches only in the French language. What about your understandability? It will be zero, right? The accuracy is zero. So I need that teacher should learn Tamil and should she teach in Tamil language. So that is the most important. So understandability of the system is required only based on the selection of your hidden neurons. The hidden neurons makes your system wise and intelligent. If you fail in selecting that number of neurons, definitely my whole system fails. If I get even it's most probability, if I substitute 10 hidden neurons, if I'm getting only 40%, I should able to do the trial and error methodology so that I can get 100% of accuracy. So this hidden neuron is important once you do artificial neural networks, right?
Sir,
Yes,
excuse
ma'am.
me, sir. Sorry for the interruption. Your presentation, we could not view it, sir. It is in the video mode.
1 minute, 1 minute.
Okay.
Is this now you can visualize, ma'am? Yeah. So the logic which comes into the all these things here is, so now we'll this. So I'll just continue with the point. Actually, this is what we call as artificial neural networks right now. So the artificial neural networks which comes into the picture is most important, and we need to select the hidden neurons for getting an output. Now, what we do with artificial neural network here is we'll get some output. There is a second category of artificial neural network, and there is a category. There is a next category of that category of artificial neural network. What we have is, assume some, we'll get an output, right? Let us assume in another example, right? If we want to write an examination, we are the data, right? We are the data, and the teacher has to train. And output from us is a pass or a 70 mark, right? What we do is we'll keep test and retest assignments, refer the books again and again until I get 70, right? If I don't get 70 at the first attempt, what I do is I again keep them to write a test, again show them everything until I reach 70. So what happens here is you have input, you have hidden neurons is selected, and output, I got an output, but output is not meant up to my threshold. It is not equal to my threshold what I obtained. What I do is take this output and give and feedback to my hidden neuron to adjust it so that I can get my particular output. And this is known to be my back propagation algorithm. So this is the vital for deep learning. So back propagation. So what is a back propagation is something like you have an input interconnected with all the hidden neurons and an output, and output is obtained. So when the once an output is obtained, I used to check up my threshold, what is to be obtained there. For example, I told you if the threshold is 70, if I don't get 70, again keep the retest and again a test assignment so that I get 70. So what happens is this has been taken as an output and given to my hidden neurons. So there is a feedback from the output to the hidden neurons. If works in this manner, this is known to be the back propagation algorithm. Right? This is the back propagation algorithm, and all the scenes in your endiran will have this ANN with the back propagation. Right? Everything, it tunes itself. Right? It tunes itself. Right? With the respective to the inputs or respective to the outputs. So this is back propagation. So what is the drawback you find over here is, the major drawback you found over here is, like, I want to make it the output revert back to my layer. So there arises a problem of gradient problems. This is called, I don't want to be a mathematical model, so it may be a gradient problem, and most importantly, time complexity. So there is a problem in the time complexity logic. So this is the basic model of back propagation and drawback. How to overcome this? We normally go for feed forward layer. Right? It is a feed forward layer. This is the most important layer which comes into the picture. It is a feed forward layer, and this feed forward layer, what you have in the feed forward layer is, it will normally works on the input logic. It normally works on the input logic. So the best example for this is extreme learning machines. Please make note of that. It is extreme learning machine. It is more widely utilized in the predictability of your electricity bills on the devices, and even stock markets and everything. So this is the logic. So you have to understand clearly this extreme learning machine, even though it was been in 1997, but today is booming up for the prediction, and it is being utilized along with the deep learning model. So its best example is feed forward. That is feed forward. No back propagation, no feedback, just an input, and you'll get an output similarly. So for that, we have to tune it, the hidden neurons, according to that. So this is the logic what we come across here. This is a feed forward and the back propagation. Now, there is a, when you say the case studies over here, these are all the scenes which we come across here. I'll explain you the conference in later on with some another more perspective logic, right? So you have an ANN, SVM, and NBDT and KNN algorithm, what we talked about. These are all the learning algorithms, and I have related with the different scenes. These scenes will explain you the algorithm, what is happening, right? Now we'll move on to the logic of a new algorithm, or a new algorithm, not a new algorithm, deep learning. Why we require this deep learning? That I told you, there is a data set, all depends upon the data what we have. The large number of data sets, in some point the machine learning fails miserably. So in order to overcome that, in order to analyze everything, we need to go for a deep learning model. So we'll go for a case study again with the deep learning models. I'll share the one video actually. So the most important thing here is, just watch out this video. I'll explain what is it. Yeah. So this is a very good example for a deep learning algorithms. Right. So I'll stop here. Then we'll go for the next case study over here. First thing is about why you require the deep learning over here. So what is the problem we have here? What is the problem you have facing here? So everybody knows about the facial recognition system, right? Everybody knows about the facial recognition system. They know what is facial recognition system is. It is utilized for your attendance and everything. Now in this case study, in this scene, you can see one application that it detects the emotions. So what is all about the scene is, the machine has been imparted with the emotions, right? So it has to understand what emotion is, whether human is emoting about. So what has been done here? So what has been done over here? Let us take this scene actually, right? So it has to understand the pain of a human. Okay. So what happens here is, like, there is a machine, there is a vision system, computer vision system. It has to gather all the application. It has to gather everything that is it has to gather all the application. It has to create a logic actually. So what happens here is, since we have been talking about these cases, right? Sorry. Oh my God. Yeah, so there is a problem. Sorry. So the logic which comes into the picture here is, so here you can see the concept of a face, and the face is recognized by the machine. So what happens here is, what happens normally here is, it has to identify the emotions. It has to identify the emotions of the human. So what it does, it extracts the different features from the faces, something called eyes, nose, even mouth, chin, and everything. So it has to extract the features, and from the features it has to identify what is the emotion by the changes in the characteristics of everything. By changing in the characteristics of everything, it has to understand the emotion of the patients, right? This is the logic. This is the logic which we have to be come across here, right? Now you just imagine, how can I able to understand the emotions over here? How can I able to do the understanding? So now the whole face is captured as a video, and now I want to extract the different features which is available, right? So what model can be utilized here, right? For example, we have an image and we need to integrate a filter. This is the basic logic. You need to integrate a filter, and the machine integrates filter over the image, right? And it rolls the filter over the complete image, so that I can able to extract the different features on the different scenarios. Hope the point is clear. That is, I'll repeat once again. The machine is there, and what happens here is, the machine applies the filter over the data, that is an image, and by each and by rolling, that is by rolling the filter over the image, it will able to extract the different features such as eyes and mouth and everything, right? This rolling concept is known to be the convolution mechanism. You would have come across in your curriculum. It is a convolution mechanism, right? Convolution is convoluting your filter along with the images, so that I can able to get the different features over here. So what happens in convolution? We have four steps. One is your shifting, folding, or it's maybe reverse, multiplying, and addition, right? So these are this is the mechanism. This is where it is being integrated in the logic to get out the different features, to get the different features. So that features will be obtained at different scenarios, eyes, nose, and everything, right? And all these things will be combined in a single model. Then we have to be label the data, and we have to give to the learning model. That is, we have to train the neural network or whatever the case is. So the convolution is designed, and based on the convolution, I have to train the neural network. When I combine, when I integrate this convolution along with the neural network, we call this a convolution neural network. This is the category of your deep learning algorithm. So it's a category of a deep learning algorithm. So I repeat once again, when I integrate the convolution along with the neural network, when I combine these two into a single module, then we call it as a CNN, that is a convolution neural network. And this algorithm plays a very, very important role in the cases of an image and video analytics. So this is most important. So video and image analysis, which we call for today in a COVID, like we are working on X-ray images, X-ray images to identify the normal flu and the corona. So this CNN manipulations in CNN can be utilized for a better accuracy, which combines your extraction of features through the future map, what I talked about with the convolution filters, along with the training with the neural network. So when I do it, when I combine it, this is known to be your CNN, convolution neural network. The best example is this. So with the help of a facial emotions, instead of recognition, we'll talk about the facial emotions, right? So what can be the advantage of this CNN? Where it can be applied? First thing is about facial emotions, I told you. Second thing is about relating the facial emotions with respect to the symptoms in our human body. This is the most important research which is going today. That is relating the facial symptoms or facial emotions with the symptoms of the body. So this is the second application where it goes for that. And third application where today we are going on is, it has been widely utilized for a smart web app system, right? I tell you on a project actually, which we are working actually. Now, like you are just seeing all this, now the videos are off. Now in a conference level, what we do, we want to see the video and the lecture is going on, right? And I need to find out whether the lecture is going on, what is the understandability, whether the user or a participant is really interested or really listening to the lecture. So this is the most important thing what the CNN is applied for. So this is a third application, and even though it is applied in the web app online training, fourth, it can be applied in your classroom sessions and conference hall also. So whenever you want to find out this kind of a facial symptoms and facial recognition, facial emotions, you can go for this kind of a CNN. And most importantly, to be generalized, you can go for any kind of an image processing system with the help of CNN. So this is the most important mechanism what we come across here, right? CNN. Hope you have understood what is CNN is. Now we'll go for the second category of an algorithm. You just check the next case study. Okay, so now this is the logic. So there will be a hormone simulation. We'll talk about what is it actually. So you have, we'll conclude that there is a image and everything. We can go for CNN and everything. And the second application, what you have seen in the case study is for the language, like it has to understand it. For the document reading, books reading, it has to understand the books reading and it has to identify the sentences, right? So first category. Second category, what we have seen is data, numerous number of time series data, right? This is what has been shown in the film. It is really time series data dependent upon the time. The data varies. When you want to concentrate on these two, and third application is a language model, to design a language model for the machine. This is where we call this NLP, natural language processing, right? So when we have these three categorization, we will normally use an algorithm called long short-term memories, right? We normally use called long short-term memories. I'll tell you how it can be applied on the each and every kind of a data, right? First, LSTM application on the document reading. First, we'll talk about the documents, right? So what you are seeing here is the book is read by the machine actually. So normally the books are being read by the machine. So my basic question is, if we read the book, right? Let us assume we are reading the book of X, right? We got the knowledge, and we read the Y, something advanced book later than X. So we read that also, right? And when we come to X, our knowledge is different, and we'll interpret different sentences, right? So that will be different. Our knowledge will be different. So this is the problem in our data. That is when you read a document kind of a data, right? Document read. So what is the problem? I told you, like, finalize, focus on it. Like when you read one document, right? When you one kind of a document, it has to read and it has to extract the knowledge and it has to predict the sentences and it has to formulate it. Second, if you read the next book, it should not be trained again. It should not be trained again. Again, I have to go for that. It should get updated by itself so that it can able to see the sentences and predict the sentences. This is the second thing. And third thing is about this is when it comes to the first book, it should not miss out the line. The line which has been predicted before itself should be the same as that of your first cases. So these are the three problems. So how come the LSTM is implemented? For this kind of an application, the long short-term memory, we will normally utilize a concept called transformer neural network. That is called TNN, transformer neural network. The transformer neural network is a category of LSTM. Why we go for TNN on rather than the LSTM? Why? Because LSTM will have again a problem when the documents are more and more of increases, then it becomes a weak. So you need to go for a changing of a module, and I have to combine with the machine learning everything to formulate a new algorithm. To solve this kind of an issue, we are now focusing on a new kind of an algorithm that is called TNN. That is your transformer neural network, right? This is being utilized to solve this kind of a problem, right? So when it's document reads, when the understandability comes, whenever it goes for NLP also, language model, this TNN plays an important role. This is the most important first case, right? Second case, what is the problem in predicting the sentences, right? I'll repeat you here again. I'll show you again a case study. What is the problem you face here? So there will be a conversation between the human and the robot.
என்னையா நோ பார்க்கிங்ல வண்டி நிறுத்திருக்க? அங்க நோ பார்க்கிங் தான் போட்டுருக்கு. டாக்டர் வசீகரம் கார் நோ பார்க்கிங் போடல. என்னையா விளையாடுறியா? இல்ல, பதில் சொல்லிட்டு இருக்கேன். ஓஹோ, ஓ டிரைவிங் லைசென்ஸ் எடு. எனக்கு டிரைவிங் லைசென்ஸ் இல்ல. லைசென்ஸ் இல்லாம எப்படியா ஓட்டுற? டிரைவிங் மாடியூல் ப்ரோக்ராம் பண்ணிருக்கேன். இந்த கதையெல்லாம் வேண்டாம். நட ஸ்டேஷனுக்கு. எந்த ஸ்டேஷன்? ரேடியோ ஸ்டேஷன், ரயில்வே ஸ்டேஷன், ஸ்பேஸ் ஸ்டேஷன், பிளே ஸ்டேஷன். என்ன லொல்ல. Right.
Here there is a problem again. This is how the problem is there when you see document, when you predict a language. Second case, LSTM, I told you, like TNN will be applied for this. Next case, there is a problem. How to make it out? So what is the problem you seen in the film? What is the problem you seen in the film is here the logic of the policeman as saying the station. We know that he belongs to a police station, but the machine cannot understand because there are a lot of stations in the mechanism, right? There is a lot of station. There was a lot of station in that. It has railway station, it has fire station, everything. So now it has to form the meaningful sentences, right? Remember, the station is a keyword, and the station, it has to be related with the police station, not with the railway station. It has to understand clearly, unless the machine fails miserably, what you are seeing today. So this is the major problem what we come across here. So how can I able to solve this? How can I able to make a mechanism? How can I make this? So for this, we'll have a block diagram for you actually. So hope you're seeing it actually. So there's a block diagram for this. So this is the block diagram. This is the second model. Sorry, this is the second model what we have, right? This is the second model what we have actually. So this is known to be your mechanism which combines your reinforcement learning with automatic tuning along with the data. So what happens? Idea, voice is transferred, interpreted, and there is a one module which calls knowledge extraction. And the knowledge extraction, which will take the previous case as one. What is the previous case is taken? Station is the keyword. So knowledge is station here. And from that, I have to relate the knowledge graph, right? The knowledge graph, we have different, you can see something called green and red and blue dots, right? So you have different dots also. That dots, the different color dots represents your different words. That is, station has to be linked with properly with the police, right? So that I can form a word called police station. So police is there, fire is there, radio is there. Now we have to establish the police station as a word, and that is being established with the help of a concept called knowledge graph. And that knowledge graph is done with the help of an algorithm called LSI clustering, right? Here the unsupervisory plays an important role. LSI clustering, this is the technique. Okay, so the knowledge, we call this entity, and we call this an entity mapping, and the knowledge graph is drawn to establish the relationship between the words, and that is known to be your concept called LSI clustering. And these two words, these two, that is knowledge extraction and the knowledge graph, when I combine it, we call this as a model called BERT model, BERT. That is the BERT model, bidirectional encoder for receiver and transmitter. This is the model which can able to extract the knowledge and the knowledge graph, primarily utilized in NLPs and document reading. And after that, it has to go for a reinforcement learning. So reinforcement plays a vital role here actually. So it learns by itself with the words which is coming out over here, and finally it predicts the sentences. So this is the next concept which the NLP people are working and the data scientist people are working on, this kind of an algorithm. So LSTM TNN is one kind of approach. Second is your manual approach with the help of a BERT model with the reinforcement learning to predict the sentences. So this is a second model where we come across the LSTM categories. Now it's been made it of the second model, right? Third, what we have, right? Third deep learning algorithm. What is the logic we come across here? Here, the third model, what we come across here is the integration of DL with ML. So this is the most important criteria in today's world, because I told you, like in a CNN or LSTM, naturally it is a neural network actually. So when I integrate what do you say, it is a convolution along with the neural network with a back propagation or feed forward, it becomes CNN. But in order to make it suitable for a wide kind of a data, so now the research is going on to integrate a machine learning over the deep learning, right? So what happened is something like I just an example. It's an inside example. You have a convolution neural network. We have taken the features. I can, instead of neural network, I can able to put up an SVM. There forms a new algorithm, right? That is CNN with an SVM. That forms a new deep learning. This is an integration of deep and machine on this case. And why do we go for this? Why do we go for this kind of an integration? So this is a very big area where we playing vital role today. Again, in case study, why we required this kind of a model for the designing. And again, I share with you the most important aspects where the 5G or whatever the case is coming into the picture. So here is the mechanism.
சனா, லதாவுக்கு வலி வந்துருச்சு. ரொம்ப சீரியஸ் கண்டிஷன். உடனே வா. ரொம்ப காம்ப்ளிகேட்டடா டாக்டர்?
நீ இங்க தானே படிக்கிற? fetal cause. தலை திரும்பி கழுத்துல கொடி சுத்திட்டு dropping pulse rate, blood loss, இருக்கிற எல்லா காம்ப்ளிகேஷன்ஸும் இருக்கு. யாராவது ஒருத்தர் உயிரை காப்பாத்துறதே கஷ்டம்.
ஐயோ, கல்யாணம் ஆன புதுசுலயே அவங்க ஹஸ்பண்ட் மிலிட்டரியில செத்துட்டாரு. இந்த குழந்தைக்காக தான் உயிரோடவே இருக்காங்க. ப்ளீஸ் எப்படியாவது 2 பேரையும் காப்பாத்துங்க.
நான் முயற்சி பண்ணதான் முடியும் சனா. அதுக்கு மேல எல்லாம்
நான் ட்ரை பண்ணிட்டேன்.
நீங்க யாரு? டாக்டரா?
இல்ல, ஐ அம் சிட்டி த ரோபாட்.
ரோபாட்டா?
சிட்டி இது உன்னால முடியுமா? வை நாட்?
சாரி, எங்களால இதை அனுமதிக்க முடியாது. இது லேப் இல்ல, லேபர் வார்ட். 2 உயிர் அண்டர் டோட்டல் ரிஸ்க். இவ்ளோ எக்ஸ்பீரியன்ஸ் இருக்கிற எங்களுக்கே திஸ் இஸ் நைட்மேர்.
என்னால முடியும். சனாவோட எக்ஸாம்ஸ்க்கு நான் படிச்சிருக்கேன்.
சன்னாவால இது பண்ண முடியாது. சிசேரியன் பண்ண யூ நீட் குவாலிஃபிகேஷன் அண்ட் எக்ஸ்பீரியன்ஸ். இட்ஸ் அகைன்ஸ்ட் தி மெடிக்கல் லா.
சிசேரியன் தேவையில்லை. என்னால நார்மல் டெலிவரி பண்ண முடியும்.
எப்படி முடியும்? 2 பேரும் செத்துருவாங்க. she is bleeding.
பிளாஸ்மா டிரான்ஸ்ஃபியூஷன் பண்ணலாம்.
blood pressure ஜாஸ்தியா இருக்கு. எந்த நேரத்துலயும் ஃபிக்ஸ் வரும்.
மேக்ஸ் ரெஜிமென்ட் கொடுக்கலாம்.
pelvic disproportion. normal delivery possible இல்ல.
பாசிபிள். சிம்பியாஸ்டமி பண்ணலாம். பழைய கால பிரசவம் மாதிரி இடுப்பு எலும்பை விலக்கி பண்றது. presentation of the employee. Then the government is in front of the presentation of the lecture. சத்தம் போடாதீங்க, பையன் பயப்படுறான். You are making history. முதல் முறையா ஒரு ரோபோ பிரசவம் பார்க்குது. பையன் உங்களை மாதிரியே இருக்கா. பாக்குறீங்களா? டாக்டர், வைஃபை ஆன் பண்ணுங்க. அல்ட்ராசவுண்ட் வீடியோ ஸ்ட்ரீம் பண்றேன்.
Yeah. So this is the most important scene, and it's a most important application when you consider everything, right? So I'll explain what is it all about, right? So first thing is about, we have different categorization. You have a decision tree learning model which has been taken place because the questions are shooted to the machine and the machine answers clearly, right? Second thing, it comes for an delivery, like it operations. So what happens here is, now you can see that this, it's a medical ultrasound video, right, has to be transferred lively to the network, right? This is the model which we have been coming across. The problem what we coming across here is, you can see here the Wi-Fi is on, and the different devices over in the Wi-Fi network can stream the device, can stream the video. So what happens is, logic is, what is the problem, real problem in this? When you go for this kind of a video transmission over the network, so ultrasound video transfer will have a consumes larger bandwidth, right? So once the devices increases, I cannot able to see what is the happening over the cases, because there is no kind of a server which is available right now. I'm loading in the server and I'm seeing it. That is not done over here. There is a network, and in the network it has to stream the video. This is the logic, right? This is the problem. So this is an IoT, actually an example of an IoT. So how come, what algorithm can be utilized? Let me have this. Hope you have understood the problem here. Let me show the block actually. So here you can see the block over here. So the block which is coming across here is this actually. So the film has been now converted into a mathematical model. So or a model, what we come across here is this ultrasound video images are being taken over here. In the film, it has been shown it is MPEG 4 compression. Now I'm just using for H.264, right? It's an encoder. What I'm calculating is, I'm calculating the bit rate, and I'm extracting the different content, right? This is known to be a content aware mechanism. This is the contents are extracted, and there is, you can see the data set is formed in accordance with the network characteristics. So network is also taken characteristics with Wi-Fi or whatever the network you have, Wi-Fi, Bluetooth, whatever the case you have, right? That network characteristics such as your delay, your PDR, that is packet delivery ratio, or even your signal strength, everything is taken into an account, and I'm forming a data set according to that content along with the network. So here I integrate CNN, right? Convolution neural network. Hope you have understood, right? So this, the images have taken, the content has to be taken. Which image, that is, every video is now converted into frames, right? And the frame will have highest, that is, which important or sensitive information. So that can be extracted with the help of a mechanism, and that has to be trained. So with the help of that, from up to the data set, I'll just go for a convolution neural network. And from that, you have a network, and from the network, it has to decide and it has to schedule accordingly which message or which information has to send first, right? According to the bandwidth available. Hope you have understood this line actually. What is the bandwidth available? What is the strength available? And what kind of data has to be sent first? And from that, for that, I will integrate a learning algorithm, any machine learning algorithm, or even an ELM, that is extreme learning machines. So here the CNN, the deep learning, along with the extreme learning machine, all been combined, and it is decoded, and you can see the images. So this is how the logic works on. So it is widely utilized in your communication side, 5G, IoT, and everything. So this is how we integrate hybrid. The two categories of our algorithm. One is deep learning, and second is your machine learning, right? So hope you have understood, right? To start, we have started with basic data. What is data is all about. And now we have seen the hybrid model. And the previous case, we talked about reinforcement. And fourth thing, we want to look about that the document which we have considered as a self-adaptive, because in the document, every time I should not train by every book, it should train by itself. So that is self-adaptive learning. And finally, the hybrid combination of algorithms. This is most widely utilized in the research actually today, right? So this is the most widely utilized. So hybrid algorithm. So starting from the data and ended with your hybrid algorithms for an application. So how can I deploy all these things into a single untested? So to this, I'll just make a word. So whenever you want to deploy it, so I'll prefer a tool called, you know about Anaconda and Python and everything. But what is the mechanism which I want to take it over your ears? That is, you need to prepare, or you need to make a mathematical, you need to formulate a new algorithm. That is most mandatory. That's what we people are looking forward for that. So for that, how you can work out of that? That is, first thing is you can learn in a two important parts. One is on the software side, and for the real-time application, you can deploy it on the hardware sector. So for the software, everybody knows that goes with the Python. I told you some of the tools, SQL, Tableau, Power BI for data analysis and data visualization. So here, for this kind of thing, go for a TensorFlow, right? TENSOR, flow, FLOW, TensorFlow, right? You can go for a TensorFlow. And Keras, KERAS, which has a deep learning and machine learning algorithms. It is already been defined, but you need to write an API which the modified with the modified examples and modified algorithm and put it on these libraries. So kindly learn TensorFlow, because this occupies a major share in everything, right? TensorFlow, right? And we talked about this, what you called as Keras. If you're not comfortable with that, you can go for a PyTorch, PYTORCH. You can go for a PyTorch for deploying this kind of a logic, right? There is a MATLAB, but we don't use MATLAB right now. I don't use MATLAB right now. So I use these kind of tools actually, right? So in order to deploy it in the hardware, so what I can do for deployment in the hardware, right? So what's the logic I'll prefer to go for you is NVIDIA, right? So you can go for a NVIDIA Jetson Nano board, right? NVIDIA, NVIDIA. That is NVIDIA Jetson Nano. If you have a GPU, it's a kind of an embedded GPU where you can port a TensorFlow, where you can port a lot of IoT with the real-time stuff. I told you it should be deployed for a real-time stuff. So this NVIDIA can be utilized for this kind of an application. So NVIDIA plays an important role, and all your automotives, all your what you say, like in case of face recognition, face emotion systems, this NVIDIA Jetson Nano plays an important role. Nearly 99% of a share market is being held by this NVIDIA Jetson Nano. It's a little bit costly, but still it occupies the major share. So kindly deploy it in kind of this, or else you can have a laptop with NVIDIA GPU. Right? If you have that category, then you forget about it and you can do it. But in case of testing into a product or a real-time scenario, this is required. So this is required for kind of a logic, right? This is one kind of a board where you can do the practice. And second thing is you can go for the Movidus, right? MOVIDUS, Movidus, Intel Movidus board, right? So Intel Movidus board can be utilized, but still it occupies less share when compared with NVIDIA. but still you can see utilize it, how it can be utilized. It is the NVIDIA, that's a Movidas board. And third thing is about, it is fascinating word which is utilized today, it's Raspberry Pi, right? If you want to start, if you have been feeling difficult to operate this NVIDIA and Movidas, whatever the board we are talking about, if you want to do with a kind of a beginner's level, you can very well start with a Raspberry Pi, but Raspberry Pi stucks with when you have a large kind of a data. So when you have large kind of a data, it stucks over here. So that is the logic what we come across here. So you can do with small kind of a data with the help of a Raspberry Pi, and the Raspberry Pi has the integrator. You can install a tool called TensorFlow Lite, Lite. You can install it and you can do it, right? So that's a case to start with the beginner, right? And the programming, Python is occupying, now SQL is making out. And I want to mention one programming which can replace all these things. That is known to be the Go programming, right? It's a Go. It is normally a Go programming. Go programming has been by Google. It is a procedural language, and it has been predicted that it can replace Python, right? It can replace Python in future for this kind of thing. So you can have awareness about what is Go is all about, right? You can have this, what a Go programming and how it is utilized for. You can have that kind of an application. And the third, what we have is Prolog. Programming is Prolog, and it is widely utilized for the PC workstations. The board called PC workstation. It's very costly board actually, and it finds a very good application in electrical vehicles, right? Managing the electrical charging point with the electrical vehicles. The Prolog is normally utilized, and the board which implies is PC workstation. So these are all the things you have to concentrate on it. So once you want to start it, you can go very well with a Pi, right? A Pi with data sets, what we have, make it out on all sort of application. Definitely you will come across what is the problem and why we go for GPUs. GPUs will have a strong pipelining mechanism where you can go for it, and you can do the pipelining with the help of a program called CUDA, CUDA, right? That is a programming which is being utilized here. And once the CUDA is installed, you can do with the wonders, you can do magics as Harry Potter with a lot of data, right? A lot of data you can come across here. So that's why I suggest you to go for a NVIDIA GPU that can be widely used for the solving a lot of data. So this is how you have to proceed with this. So learn Python, but Python, in case of, don't make it like substitute all the libraries which is available. See that area, what is data is already available. Don't do that. Take some real-time samples, what I told you, put up with the libraries what you want, and see what is happening. If that case has happened, I'm sure that you can come up with a flying colors on a lot of stuff, right? So that's what is the thing is, we started from basic level, and we have told you how to deploy it, a lot of algorithms with a lot of case studies, right? If you have any queries, you can ask me right now.
Thank you so much, sir. That was really a wonderful session and an interesting session too. We convey our heartfelt thanks to you for sharing your valuable knowledge with us.
Thank you, ma'am. Thank you. Thanks a lot. Any queries?
We will see to it, sir. If we have queries, we will go further. The first question is about Tableau, sir.
Yeah.
Initially, you told about Tableau.
Yes, ma'am.
How to collect the data using Tableau, they have asked.
Right. The Tableau is not for a data collection. It is for the data analysis and the data visualization, right? If you have a data, right, if you have a completely data, for example, to start with, you can download the data from a Kaggle, right? So Kaggle website gives you the free data which can be available, and you can install a trial version of Tableau on your system, and you can feed the data. It also supports your Python. So you can feed the data on the Tableau and you can visualize it. This is the first step what to work on the Tableau, because in industry, what we do is normally in the Tableau will be installed on my server side, right? So it will be on the server side. And what happens here is, or else it will be on my touch panel, whatever the case you want. And all the devices will send the data to my servers, and the servers will do sort of lot of analysis through Tableau. So that is completely a different task to operate it. So instead of that, you can download the data, which you can have it on the Kaggle. And after downloading it using Python, you can make it on the Tableau to visualize how it has been working. So that will be a correct point to start with the Tableau, right?
The next question is, what are the opportunities to freshers?
Opportunities to freshers. To be frank with you, there is no kind of opportunities. unless, unless otherwise you have a skill, right? So the freshers, like what we expect is, because we are also recruiting a lot of interns, right? So what is the basic skill we require is, So understandability of a learning model. So that's why we made a case study with a film actually. So understandability of the model. And second thing is about like how do you work on the model. So mathematical knowledge, that is mandatory. And Python, if you know Python on that, then it is well and good. These are the three primary things. But in industry, when you are ready to learn, you are giving that's Tableau and everything you can do with a lot of wonders, right? So as far as the freshers is concerned, my best advice is start, if you want to go for into a data or a data analysis, data science, start from the third year onwards, right? Start with the third year onwards and do a lot of that data analysis and manipulations, everything, and learn some trial versions, which is because Tableau is majorly occupied in industry. Nobody knows about it, to be frank with you, right? The people are in demand, but we couldn't have a skilled people to work on that. So that kind of a thing. Choose this and start from the third year. Go for an intern for the final year. If you have been okay, then there go for you. There lies a lot of opportunities for you. So that's the procedure. You can go for that. If you know, if you know Python, everybody knows with the Python. Everybody comes with Python, right? So that it looks odd, right? You must be you looking so unique. So start from the third year, and if that is the case, you are in actually.
Thank you, sir. Next question we have from Kritika. She have asked, what are the skills required to develop the knowledge on Power BI and Azure?
Power BI and Azure is something like Azure. You have a C Sharp, and even today Python is required. But what do we use this Python? Where do we use this Azure or AWS or Power BI? So this makes a mandatory. So choose your field actually. My like if you are electronics and communication student, choose the Power BI or Azure for your electronics and communication domain, because the domain specific knowledge is required for solving all these things, right? Integration of domain specific along with this deep learning and machine learning, and try to integrate machine learning on Azure, right? So you have Azure model deployment of models on Azure itself. You can deploy and see it. And third thing is about you can go for big ML, right? That is most important case, big ML. This is all for the beginners I'm talking about. It is a big ML where you can see like you have a cloud data, and the cloud data can integrate it with ML. With you can design your own model, right? Not a own model, the model which has been there. So you can design that. You can opt for these three. But the case is when you want to shine in this field, you are supposed to learn about the mathematics very well. That is important. Without that, you cannot go with that. You cannot modify. You cannot change the algorithm and everything. Remember, the modifier or a data analysis, the data scientists are paid more today. And what their job is, they have to come out with the new algorithms, which is required. So the payment, the package is something very different. But this skill is to be required, and this skill has to be developed. The tool can be anything, right? Tool can be anything. It's kind of a deployment. The tool is kind of a deployment, but how the algorithms are formed and how it is can be designed, that makes the sense. So if you can learn with a mathematical background about all these algorithms, then it's fine and great.
Thank you, sir. We have the next question regarding Python.
Yes,
They've asked whether Python or R programming, which one would you prefer for text analytics?
We will normally use Python, right? Text analysis, we normally use Python actually, because Python has an inbuilt libraries instead of R. We have the Python is user friendly for that. So you can utilize Python for that. And most importantly, there is a tool called SCAPY, right? You can use this library, right? SCAPY, right? For the text analysis. Okay. So this is a library which is normally utilized nowadays for a text analysis.
So the next question is related to support vector machine, sir.
Yes, ma'am.
They have asked whether support vector machine can be used to identify measurements.
Can be used. Yes, it can be. It can be utilized to identify the measurements. Definitely, it can be utilized.
The next question is about deep learning.
Yes,
After deep learning and reinforcement learning, which concept may come in future?
That's what self-adaptive learning algorithm, which I talked about. So self-adaptive algorithm is most important. And you can see, if you have been very interested in the 2.0, this word has been mentioned in the film, self-adaptive learning algorithm. So it learns from the environmental conditions. It learns. That's what I told you. It's one time trained, and it should get updated by its training methodology and from the environmental condition. I need not sit and train the machine again and again. So this is the most important. So self-adaptive learning algorithm, where it combines your machine learning, deep learning, hybrids, and everything. So that is something, a new world which the people are focusing today.
We have the last question, sir.
Yes,
How could robotics data controlled by machine learning?
See, the robotics data like machine learning has been integrated in your hardware actually, in your CPUs actually. So whenever you take the CPUs over here, whenever you take a logic for the CPUs will be integrated this kind of a learning algorithm where the inputs and outputs can be determined. For example, when you see the film, first of all, the robot can able to analyze the voice and it can able to analyze the text, and also it can able to go for the video analytics also, right? These three things all been taking place parallelly for on based on the hardware. So the machine learning is utilized in the hardware as a separate sector. Okay, so for the video learning, this learning model comes into the picture and this is the output. So this is being made as a common methodology. And the programming methodology, what is being utilized for updating, if you want the updation in your machine learning to the machine, we normally use a programming called OTA, over the air programming for robotics, right? Over the air, where I can sit somewhere else and with a server I can do the robot updation. So that has been done today. OTA programmings are being done with it. So this is the scenario of whole industry of which has been doing right now.
Sir, we have got few more questions. Can we
Yes, ma'am.
continue, sir?
Please, ma'am.
Yes, sir. How to connect big data analytics in Python?
See, big data analytics, you have a Hadoop framework for that. If you want to try, really work on the big data, I'll tell you a methodology. You can go for SQL Server, right? You design your own SQL databases with a lot of data, right? And from that, you can develop a Python API where you can do it and implement a machine learning over that kind of a data. This is a simple methodology. It's not a simple methodology. It's a beginner's level methodology where you can do such a side of applications. So you can develop SQL databases where you can store a lot of data, do the manipulations over here, and you can integrate a Python. That's why I told you it's a big ML can be integrated with your big data. That is what is called big ML, right? Big data analytics. That is, it combines your machine learning for the big data. To create that big data, you can go for a SQL databases. So you can opt for big ML. That's a logic.
The next question is, can you explain reinforcement in short, how it is possible in a machine?
See, reinforcement is something like it takes from the errors actually. So not an errors by tuning it's itself, right? So for example, when I want to play the video, right? When the Indian movie is being played, there is a first scene that the robot walks over here, starts walking, right? And it walks its own style. It walks its own style. So what happens is there is a command from the scientist that it has to walk according to the scientist. What it does, it takes the command and it learns itself and trains itself, and so that the motors are controlled according to that. So this is known to be the reinforcement, simple reinforcement learning algorithm, right? Which tunes it automatically, depends upon the outputs and inputs. So that is the reinforcement learning, and it plays a vital role not only in robotics, what we talked about, plays a vital role in the 5G actually, 5G communication.
The last question, sir. As a fresher, what language would you recommend to study? C, C++, Python or Java? Which language is most important?
Which language is see, it depends upon the domain. It's basically a domain. So for an image processing and everything, we'll integrate nowadays, we'll integrate C++ and Java, right? And for integrating an algorithm, we integrate a Python. And for the hardware deployment, we normally use C, right? And the Go programming, what I told, is particularly based on C programming. So it doesn't differs which you learn and what you learn, right? How you learn is important. So choose one particular language, master in it, and go for some real-time projects which can solve the problems in the real-time solution or provide the real-time solution. So if that is the case, you can end. Doesn't mean that you only know this. If you study only this, you can into the industry. That is not the case here. If you are knowing what you want, and if you are strong, if you have been strong, what you learn, then it is implied. Because whatever the language you told me, like it's everything is implemented in each and every cases. So that makes the difference, and that makes a hot cake. So learn and strong in that, experiment yourself, and you are into the industry, right?
Thank you so much, sir.
Thank
The
you, ma'am.
session was really interesting. With one Indian movie, you showed all the algorithms related to machine learning and other techniques.
Thank you, ma'am.
We thank all the participants for joining with us today. Hope you would have enjoyed the session well, and most of the questions have been answered by the speaker. Our upcoming webinar is on Future of Industry 4.0 Post COVID 19 Paradigm by Mr. S. Kalidasan, Project Head, Access Global Solution Chennai, scheduled on June 17th, that is tomorrow, from 11 a.m. to 12 noon. I request all faculty and students to attend the webinars and get benefited. I kindly request the participants to fill the feedback link with correct mail ID. Link for feedback form and e-certificate will be posted in the chat box. Participants kindly complete the feedback form within 30 minutes after session gets over. We like to inform that feedback link will not be shared through WhatsApp or mail. I once again repeat, I kindly request the participants to fill the feedback link with correct mail ID. Please fill the form and receive your e-certificates through mail. Thank you all for your participation. Stay safe.